Short circuit evaluation happens when only part of a Boolean expression needs to be evaluated in order to determine the value of the expression. So this works whether we're using and or in our Boolean expressions. We'll look at an example of each. So in our example, we have two doubles, x and y. The first expression is a compound Boolean expression that uses the and symbol. So both sides, both the left and the right, need to be true in order for this entire expression to be true. So the way that Java evaluates this compound Boolean expression is it first evaluates the left-hand side. So it checks, is y not equal to 0? In this case, y is equal to 0, so it knows that this side of the expression is false. Since one side of the expression is false, Java actually won't check the other side because it knows that the entire expression is false. It doesn't matter what this other side is, if it's true or false. Once we know that the left-hand side is false, then the entire expression has to be false. So it only evaluates this side. Since it's false, it stops. And then we skip over the if statement. Now if y wasn't 0, then this side would be true and we would have to go evaluate the second side to know the result of the Boolean expression. So it only evaluates part of it when it can determine the final result from just that part. In our second if statement, we have another compound Boolean expression, this time using the or sign. So if either the left side or the right side is true, then the entire expression is true. So again, it's going to start with the left side and evaluate. So x equals 25 is true. Since that side is true, it doesn't matter what the left side is, if it's true or false. We already know the entire expression is going to be true because it only takes one side being true to make the entire expression be true. So again, it's just going to skip that right-hand side. And since the expression evaluated to true, it's going to go into the if statement and print out this statement, the expression is true. And you can see that over here that it prints out. So this is called short circuit evaluation, where only part of the expression needs to be evaluated and is evaluated, and the part that doesn't need to be evaluated isn't evaluated. This is useful for two reasons. One is it can speed up our code if we don't have to evaluate as much of a very long Boolean expression. So these are very simple examples, but if we have complex examples, then the time that it takes to evaluate part of the Boolean expression can actually be significant. So not having to evaluate it is useful. It speeds up our program, especially if we're repeating the code over and over again. So if we have a loop or just running some process over and over again, little improvements in how fast it runs can start to add up. The other reason why short circuit evaluation is so useful is it can prevent errors when we run our code. So if we go back to our first example, if we had evaluated this this right-hand side of the expression, we would have been dividing 25 by 0, and that would cause an error, and our program would actually have crashed because you can't divide by 0. So it's really important that Java uses short circuit evaluation, and once it realizes y is 0, then it won't evaluate this right-hand side, and that will prevent that error from happening. So we'll never divide by 0. So if you want to check something before you run the other part, you might want to use an and, make sure that something is true, for example, that your denominator isn't 0, and then do some sort of calculation with that value.